Shanghai Kepler Robotics just dropped a massive update for their humanoid robot, the K2 Bumblebee, and it is an absolute game changer. They've not only given it a major gait upgrade, but they've also released what is being called China's first ever demonstration of a hybrid architecture disturbance-resistant gait. The video shows this full-sized humanoid robot walking with insane stability over a minefield of uneven bricks, slippery plastic, and soft, unpredictable grass. And it doesn't just walk, it takes pushes and shoves like a champ, barely flinching, maintaining its balance like a seasoned martial artist. This isn't just a lab experiment. This is a statement of intent, showing the world that this robot is being built for the messy, the unpredictable reality of our world. They showed off their VLA Plus training platform, which is essentially the robot's brain. This is how the K2 interprets your plain English or Mandarin commands and turns them into actions. You can tell it to go grab a tool, inspect a panel, or navigate to a point, and it understands reasons and plans how to do it. This 1-2 punch of insane mobility and advanced cognition is what sets the stage for this robot to actually step out of the R&D lab and into real industrial plants, service roles, and more. This dual upgrade is the key that unlocks practical, real-world use. All comes down to a commitment to a brutally complex but incredibly effective hardware. Most robots you see use simpler rotary actuators there, like constantly bent knees, which is easier to engineer but less efficient and less natural. Kepler's K2 combines linear actuators which act like the powerful muscles in our thighs and calves, with rotary actuators for fine-tuning. This series parallel configuration is what allows for that straight-knee gait you see in humans. It's way harder to pull off, requiring insane levels of precision in kinematic modeling and torque control, but the payoff is huge. A more natural walk, way better energy efficiency, we're talking 81.3% energy conversion efficiency, stronger task execution, and superior adaptability. This is a design pathway that other leading humanoid robot companies are also chasing, because it simply delivers superior performance. But going from a great idea on paper to a robot that actually walks stably in the real world is a monumental engineering challenge, famously known as the simtorial gap. You can train a robot to walk perfectly in a simulation with perfect, uniform ground, but the real world is chaos. A concrete floor isn't uniformly concrete. It has cracks, dust, and slightly different friction everywhere. This discrepancy causes robots to slip and fall. Kepler's team tackled this by smashing together reinforcement learning, imitation learning, and incredibly precise torque control from those linear actuators. They trained the robot in simulation to build general skills, but then used real-world data to teach it how to handle the chaos, even dynamically switching its gait on the fly. And that brain upgrade, the layered VLA Plus model, works on the same principle, training on simulated data for broad understanding and then refining on real-world human data for practical execution. It's a continuous learning flywheel that makes the robot smarter and more capable every single day. The K2 Bumblebee is no longer just a cool demo. It's a platform steadily expanding into real application scenarios. We're talking commercial uses right now in research, education, and public exhibitions. But the big ticket is industrial deployment, logistics and material handling in warehouses, assembly tasks in smart manufacturing, and specialized operations that are dull, dirty, or dangerous for humans. With a 30 kilograms payload capacity, an 8-hour runtime on a 1-hour charge, and over 80% of its hardware developed in-house for cost control, Kepler isn't just building a fancy robot, they're building a viable commercial product. 2025 is being hailed as the year humanoid robots truly start to commercialize, and with this update, Kepler's K2 Bumblebee isn't just entering the race, it's coming out swinging with a compelling blend of bleeding-edge biomechanics and artificial intelligence. This is what a true general-purpose humanoid robot looks like, and it's happening right now. If you're as excited as I am to see where this goes, smash that like button, subscribe for more deep dives into the world of robotics, and let me know in the comments below.